Algebra 2, lesson 16.1, page 790. It says, express each expression as a single logarithm. Simplify if possible. So we have log base 912 plus log base 9, 546. We can make it into a single logarithm by log base 9, and then that's 12 times 546.75. And let's see, 12 times 546.75. And that's 6561. So that's going to be log base 9, 6561, which is just 4. Okay. And then, so you multiply if they're adding, so you're going to divide if they subtract. So you got log base 2, and that's going to be 76.8 divided by 1.2, and that's going to be log base 2, 64. And you might say that's log base 2 to the 6th power, which is 6 times log base 2, or just 6, or equals 6. Number 3, log base 2/5, 0.0256 to the 3rd power. So I'm gonna, let's see here, I'm gonna move that up front, and that's gonna be log 3 times log base base 2/5, and then 0.0256. Okay. And what I can do here is I can say 3 times log 0.0256 over log 2/5, and that's going to give me 3 times 4, which is 12. All right, and just to show you that those are all equivalent, let's see, we got control log, and we've got 2 divided by 3, and let's see, tab 0.0256 caret 3. Whoa, what did I do there? That's 2/5, not 2/3. That is 2/5. And there we go. All right. And then let's see, what was the next thing I showed you? 3 times, and then open parentheses, control divide, and I got log 0.0256. Tab 0.0256, and then log, and that's 2 divided by 5, not 3, but 2 divided by 5, and that gives you 12. Okay, so it gives you a little bit. Now, look at here, we've got, and that's going to be 23 times log base 11, and log base 11 is just 1, so that's going to be 23 times 1, and that equals 23. So the exponents, you move around to the front and then multiply. Okay. Number 5. Might need a little extra room here. I'm going to move this x plus 1 up front. x plus 1. I can do that with the exponents. And log base 5 plus, and then see these have different bases, so I can't multiply them. And then I move that 2, and that's going to be log base 4 to 56. And so this equals 1, so I've got x plus 1 plus, and then, well, let's see here. That's 2 times log base 4, and that's 4 to the 4th power. Okay, so x plus 1 plus 4, I'm going to move that up. 4 times 2 is, wait for 8. And then log base 4. Again, that equals 1. So 1 plus 8 is 9, and I have x plus 9. Now let's take a look. Oh, now these have the same bases, so I've got, and I'm going to move this x up front here. And I got log, and then I got log base 7, and I got 98 divided by 2. Okay, ooh, yes. All right. Well, 98 divided by 2 that's going to be log base 7, and that's 49. Well, let's see, 49, that's the same as 7 squared, right? And you know something? I got this up here. Let's leave that right there. I didn't, because that, anyway, let's leave it right there. Okay, that's outside of log base 7. Okay, so, and then that's there. Okay, well, 7 squared, so that's going to be, well, this becomes 1, so I got log base, and that's going to be 2 to the x power, and, well, and then that gives you x log 2. All right? And yes, you could have, yeah, that could have been out there, and that could have been out there. I was scared though that when you move that, you got to move it in, it stays inside the parentheses, it doesn't go out. Number 7, you have log base x plus 1, and then you, let's see here, x squared, that's x plus 1, and that's squared, right? That is squared. All right, so we can get rid of this parentheses here. We'll say log base x plus 1, and that's going to be x plus 1. 2 times 3 is 6. You can move this out front. You got 6 log base x plus 1, x plus 1. Those two will cancel out and become 1, so you have 6 times 1, which is 6. All right, we got log base 4, and log base 4. All right, so let's do the first two. That's going to be log base 4, and then 5 times 12. Well, 5 times 12 is 60, minus log base 4, 3.75. Now I can combine those. I got log base 4, that's going to be 60 divided by 3.75. Well, that's going to be log base 4, 16, and 16 happens to be 4 squared. So that's going to be 2 log base 4, 4, which is 2 times 1, or 2. Not bad, not bad. So what do we got here? Seismologists use the Richter scale to express the energy or magnitude of an earthquake. The Richter magnitude of an earthquake M is related to the energy alg, shown by the formula M equals 2/3 log E to the or divided by 10 to the 11.8 power. In 1964, an earthquake centered at Prince William Sound in Alaska registered a magnitude of 9.2 on the Richter scale. Find the energy released by the earthquake. So we got 9.2 equals, and then we've got 2/3 log, and that's E over the 10 to 11.8 power. All right. So I'm going to divide both sides by 2/3. So 9.2 and divide it by 3. 2 divided by 3. 2 divided by 3. Oh, how did I do that? 2 divided by 3. And that gives me 13.8. So I have 13.8 equals, and then log E, I'm going to rewrite that as log E minus log 10 to 11.8. Okay? Now log 10 is just 1, so I can, let's see, we got 13.8 equals log E minus, and that's going to be 11.8 log 10. Well, log with the unspecified base is log 10. So log 10 here is 1. All right, 11.8 times 1 is just 11.8. So now I'm going to add 11.8 to both sides. And let's see, that's going to give me 25.6 equals log E. Well, I got to get rid of this log thing because I want to know what E is. So I'm going to make it exponents. And that's going to give me 10 to the 25.6 power equals E. And let's see. Well, so you might say E equals 3.98 times 10 to the 25th power. Okay? And that's 25 zeros after this point here. The difference between the apparent magnitude or brightness M of a star and its absolute magnitude M is given by the formula M minus M equals 5 times log D divided by 10, where D is the distance of the star from Earth measured in parsecs. Find the distance D of the star Rho Orph from Earth, where Rho Orph has an apparent magnitude of 5 and an absolute magnitude of negative 0.4. So I'm going to have 5.0 minus negative 0.4 equals 5 log D over 10. All right. So that's going to give me 5.4, and then I'm going to divide both sides by 5. Gives me log, that's going to be D minus log 10. So 5.4 divided by 5, 5.4 divided 5, that's going to be like 1.08. So I got 1.08 equals log D, and log 10 is 1. So if I add 1 to both sides, I got 2.08 equals log D. Now I need to get rid of the log, so I'm going to make those exponents. And that gives you 10 to the 2.08 power equals D. And let's see, 10 caret 2.08, that's 122.2 is approximately D. So 120.2 parsecs from Earth is where that star is. The intensity of the sound of a conversation ranges from 10 to the negative 10 power watts per square meter to 10 to the negative 6 power watts per square meter. What is the range of the loudness of the conversation? Use I sub 0 equals 10, or the initial whatever, equals 10 to the negative 12 watts per square. So the loudness, and you got to go back into your thing to get the formula, but let's see, loudness, and that's going to be 10 to the negative 10, is 10 log, and that's going to be 10 to the negative 10, 10 to the negative 10, over 10 to the negative 12, which is going to be 10 log, and that's going to be 10 squared. Well, I'm going to move this up front, and 2 times 10 is 20, log 10. Well, log 10 is 1, so basically it's just 20. Now the lower end is going to be 10 to the negative 6, it said. That's a whisper, not really, but anyway. And it's going to be 10 log, and that's going to be 10 to the negative 6 over 10 to the negative 12. You're about to find out it's going to be a lot louder. Equals 10 log, and that's going to be 10 to the 6. Well, again, we move this up front, and that gives us 60. So it goes from 20 decibels to 60 decibels. The loudness goes from 20 decibels and to 60 decibels. All right. Let's try one more. Have y'all ever been to the UT football stadium? Boy, it's loud, isn't it? All right. The intensity of sound from the stands of a football game is 25 times as great when the home team scores a touchdown as when the away team scores. Remember, when the away team scores, you say, good for them. Find the distance. So we're going to have L, and that's going to be 25, and we'll say I minus L to the I. All right. So let's see, what do we got? And that's going to be 10 log, and we're going to say 25I over I sub 0 minus 10 log, and then we've got I over I sub 0. So they both got 10. We can take the 10 out, and that's going to give us log 25I over I, the initial, minus log, and that's just going to be I over, and there we go. Well, let's see here. We can kind of do some splitting up here. 25, we can take that out, and we can say 10, and that's log, and we'll say 25 I over I sub 0 minus log I over I sub 0. And then we can divide that up. 10, and that's log 25 plus log I over I sub 0 minus log I over I sub 0. Now, we did that because these two will cancel out, all right? So you end up with 10 log 25, 10 times log 25. So we got 10 times log 25, and that's 13.98, which is approximately 13.98. So the difference in the loudness of sound is about 13.98 decibels. Yeah, let's try number 13. A stock priced at $40 increases at a rate of 8% per year. Write and evaluate a logarithmic expression for the number of years that it will take for the value of the stock to reach $50. Okay, we usually use P equals the initial principal of 1 plus R to the T power. Okay, so we're gonna make that into a log. So we got log 1 plus R P equals log, and that's 1 plus R P sub 0 times 1 plus R to the T, right? And let's see, we better put all of this in there. All right, just like that. Okay, now we said we had 8%, right? So 1 plus 0.08, that's going to be log 1 plus 0.08 P equals, well, what was P? Well, that would have been $50, right? So we'll put $50 in there, equals log, and then 1 plus, I'm going to just put 1.08, I did the math there, and that's going to be P sub 0, which is $40. And then we're going to have 1 plus 0.08 T. Right? Well, we can split that up a little bit. And so we got log, and then we'll just do 1.08 50 equals log 1.08 40 plus log 1.08 to the fourth. Well, to T. I don't know why I said fourth. T. All right. Now that's going to move up here in front. Okay. That's going to move up there in front. So let me go ahead and put that up there. Plus T. All right. That sets up for the next thing. I can subtract this, and I get log 1.08 50 minus log 1.08, 40 equals t log 1.08, 1.08. Now, that's going to cancel out and become 1, right? So now I have log 1.08, that's going to give me 50 over 40 equals t, which is going to be approximately, when you put it in the calculator, approximately 2.9 years. It will take 2.9 years for that $40 to become $50. And let's try number 14. Suppose the population of one endangered species decreases at a rate of 4% per year. In one habit, the current population of the species is 143. That's one habitat. How long will it take the population to drop below 30? So we might say that the principal is 30. The initial principal is 143, and the rate is 1 minus 0.04, which is 0.96. Okay? Now, we did this just a little bit ago, and we said log base and the rate, that's going to be 0.96, and that's going to be 30. Equals log 0.96, and we're going to have 143 times 0.96 to the t, and all of that is in parentheses. Okay, now we can do like we did before. Log base 0.96, 30 equals log base 0.96, 143 plus, and then we'll move the t up front, t log base 0.996, 0.96, okay? Those two will cancel out and I'm left with t. I'm going to subtract this to the other side. Log base 0.96, 30 minus log base 0.96, 143 equals t. So we got log base 0.96, that's going to be 30 over 143 equals t. If you put that in your calculator, it's going to be about 38.3 years. So after about 38.3 years, the population of that endangered species will drop below 30. I would like for y'all to do number 15 on your own and show your work. Show your work. Thank you. Have a wonderful evening, and I'll see you tomorrow in class.